Now in the session of video we are going to discuss class 12th maths. Today we will discuss differentiability part 2. In previous part we have discussed about what is differentiability, the graphical representation of differentiability at any point, कैसे हम लोग किसी point पे differentiability find out कर सकते हैं. Today we are going to discuss a theorem and also the problem based on this. So the theorem is that if a function is differentiable at point, it is necessarily continuous at that point. फंक्शन क्या होगा, डिफरेंशिएबल है किसी पॉइंट पे, क्लियर, सो वो कॉन्टिन्यूस भी होगा. बट कन्वर्स इज नॉट ट्रू. कन्वर्स मीन्स इफ द फंक्शन इज कॉन्टिन्यूस सो इट इज़ नॉट नेसेसरीली एवरी टाइम दैट इट इज़ डिफरेंशिएबल. कॉन्टिन्यूस होगा तो डिफरेंशिएबल होना ज़रूरी नहीं है, बट डिफरेंशिएबल है इट मीन्स वो कॉन्टिन्यूस है. अगर आपको कहीं भी गिवन है द फंक्शन इज डिफरेंशिएबल एट एक्स इज इक्वल टू सी, इट मीन्स एफ एक्स क्या है, कॉन्टिन्यूस है. बट कॉन्टिन्यूस है और सी पे वो डिफरेंशिएबल भी होगा, ये जरूरी नहीं है. क्लियर. नाउ लेट डिस्कस द क्वेश्चन. इन दिस क्वेश्चन यू विल नो अबाउट हाउ टू फाइंड आउट अ फंक्शन इज डिफरेंशिएबल एट दैट गिवन पॉइंट और नॉट. सो वी हैव सो दैट एफ एक्स इज इक्वल टू मॉडुलस ऑफ एक्स इज नॉट डिफरेंशिएबल एट एक्स इज इक्वल टू सी, एक्स इज इक्वल टू 0. सो एक्स इज इक्वल टू 0 पे हमको क्या करना है, डिफरेंशिएबल प्रूव करना है. क्लियर. सो क्या होगा, हमको क्या निकालना है, विल फाइंड लेफ्ट हैंड डेरिवेटिव एंड राइट हैंड डेरिवेटिव. एंड इफ लेफ्ट हैंड डेरिवेटिव इज इक्वल टू राइट हैंड डेरिवेटिव सो इट मीन्स वी कैन से इट इज डिफरेंशिएबल, अदरवाइज नॉट. सो सॉल्यूशन, वी ऑब्जर्व दैट लेफ्ट हैंड डेरिवेटिव at x is equal to 0, left hand derivative at x is equal to 0, limit x tends to 0 negative, fx minus f0 upon x minus 0. क्लियर. आपको पता होगा 0 is c, so we can write it as fx minus f0. f0 को हम क्या ले सकते हैं, यहाँ पे fc होता है अपॉन x minus c. क्लियर. और लिमिट वट एवर वी आर टॉकिंग अबाउट, लिमिट x टेंस टू 0 नेगेटिव. क्लियर. इस फॉर्मूला का यूज़ करेंगे. सो इन दैट केस c इज इक्वल टू 0, सो क्या होगा, x माइनस f0 अपॉन x माइनस 0. Clear. Now let us solve this. Is equal to, in place of x we have to put up left hand derivative, so we can write it as limit h tends to 0 f 0 minus h minus f0 upon 0 minus h minus 0. Further, limit h tends to 0 f upon minus h. So left hand derivative at x is equal to 0. Further, limit h tends to 0. So what is fx? fx is mod of x, so we can write it as modulus of minus h minus 0 upon minus h. So if we solve this, so limit h tends to 0, it is plus h upon minus h. So our answer is minus 1. Clear. Similarly, now find out RHD, right hand derivative. In this right hand derivative we have to done same right hand derivative at x is equal to 0. Further, limit x tends to 0 plus f x minus f0 upon same thing we apply x minus 0, formula ये apply होगा. Okay, limit h tends to 0, then f 0 plus h, clear, minus f0 upon 0 plus h minus 0. Limit h tends to 0, so function, put up the value of function fx is equal to क्या given है हमको, modulus of x. तो कैसे रखेंगे, 0 plus h means h, so modulus of h upon h means it's 0 0, this is 0. So further we can solve limit h tends to 0, it is 1, and finally answer is 1. So now concluded that overall left hand derivative at x is equal to 0 is not equals to right hand derivative at x is equal to 0. So fx is not differentiable at x is equal to 0. Now next we'll see one other question. Okay, now we have another problem. Show that fx is equal to x square is differentiable at x is equal to 1 and find f dash 1. So first of all we have to prove it is differentiable at x is equal to 0, x is equal to 1. So clearly मैंने आपको पहले बताया, we can find it very easily. Find, we observe that left hand derivative at x is equal to 1. So we can write it as limit x tends to 1 negative fx fx minus f1 upon x minus 1. Okay, further we can write it as limit h tends to 0 and limit, in place of this, f h x minus h means what we have given function, so 1 minus h minus f1 upon 1 minus h minus 1. Clear? Now we can solve this. Okay, so we can solve, this is cancel out, f 1 minus h, so the function we have given limit h tends to 0 and 1 minus h whole square minus 1 whole square. Why? Because the function is given to us fx is equal to what? X square. Clear? Okay, solve this upon minus h. So on solving this we get limit h tends to 0, 1 plus h square minus 2h minus 1 upon minus h. So it is cancel out. Limit h tends to 0, so h can be taken out, so h minus 2 upon minus h. So if we solve this, so it is cancel out and limit h tends to 0, we can write it as 2 minus h. So on putting the value h is equal to 0, so we get 2. So this is our left hand derivative at x is equal to 1. Now right hand derivative at x is equal to 1, right hand derivative at x is equal to 1. Similarly, with the same manners we can solve this. Limit x tends to 1 plus fx minus f1 upon x minus 1. Limit h tends to 0, f1 plus h minus f1 upon 1 plus h minus 1. So it is cancel out again. Limit h tends to 0, Now function is given fx is equal to x square, so we can write 1 plus h whole square minus f1 upon h. So on solving this, we get limit h tends to 0, 1 plus h square plus 2h minus 1 upon h. So it is again cancel out. Limit h tends to 0, so we can take common h again. So h plus 2 upon h, this cancel out, again we get 2. Clear? So we can say that left hand derivative at x is equal to 1 is equal to right hand derivative at x is equal to 1. Hence fx is differentiable at x is equal to 1. Now the second question, we have to find f dash 1. So f dash 1 is equal to what? We have 2. Clear? So overall in both of things we'll see that.